Okay, so in introduction, a gravimetry technique is based on the measurement of mass loss or mass gain of test specimen using analytical balance with high precision and sensitive are effective ways to evaluate the material degradation as a function of exposure times or temperature in corrosive environments. Gravimetry also is a fundamental and versatile analytical technique centered on the precise measurement of mass changes, and it can be effectively utilized in two distinct ways. Gravimetry also is a technique based on measuring the mass of precipitate formed from a chemical reaction between an analyte.
Moving on the theory section, which focus on the characteristic and stability of our specimen. First, we look at silver. It is a precious metal renowned for having the highest thermal and electrical conductivity. In its commercial form, silver granules typically have an exceptionally high theoretical purity of 99.9% pure silver. Secondly, in this gravimetric analysis, the silver granules serve as our sample, while the silver ions are the target analyte that we aim to isolate and quantify. Finally, the core principle of gravimetry here is used to determine the actual percentage of silver within the sample. We do this by measuring the mass of the isolate metallic silver. The experiment value is then correlated and compared back to our 99.9% theoretical purity standard. With that, I will hand over the presentation to the next speaker for the methodology. Thank you.
Hi, my name is dayang NATASHA binti MAROT, and I will continue this video presentation. So, what is the objective of this video presentation? The objective is to understand the principles of precipitation gravimetry used in the quantitative determination of silver granules. And second is to determine the mass of silver in the sample of silver granules using gravimetry method.
Next, I will explain the methodology of our experiment. First, 5 grams of silver granules were soaked in a mixture of acetic acid, CH3, COOH, and hydrogen peroxide, H2O2. The purpose of this step is to clean the surface of the silver granules. The silver granules were left in the solution for 45 to 50 seconds. This soaking time allows the chemical mixture to penetrate and dissolve the layer of dirt and contaminants of the silver surface. After soaking, the silver granules were rinsed with deionized water and then placed in an ultrasonic bath. The ultrasonic bath removes any remaining dirt and chemical from the surface. Next, the clean silver granules were dissolved using nitric acid or HNO3. In this reaction, solid silver is oxidized into silver ions. The oxidation reaction is Ag to Ag charge positive plus E negative. This means that silver atoms lose electrons and become silver ions in the solution. After the silver had dissolved, 10 to 15 millimeters of 5% ammonium hydroxide NH4OH were added. This is an important purification step. Ammonium hydroxide helps remove unwanted impurities. Next, 8 to 10 grams of hydroxylamine hydrochloride were added. This chemical acts as a reducing agent, converting the dissolved silver ions back into the pure metallic silver. The reduction reaction is Ag charge positive plus E back to the Ag. As a result, silver particles begin to form as a solid precipitate. The mixture was then heated to 70 to 80 degrees Celsius for about 2 to 3 minutes. Heating speeds up the chemical reaction and helps complete the reduction of silver ions into metallic silver. A G4 crucible was weighed using an analytical balance. This initial weight was recorded so that the mass of the recovered silver should be accurately determined after the experiment. The silver precipitate was separated using vacuum filtration with the pre-weighed G4 crucible. The precipitate was washed several times with deionized water to remove any remaining chemicals and soluble salts. Finally, the silver precipitate was dried in an oven at 120 degrees Celsius. This removed all remaining moisture so that only dry silver remains. Finally, after the silver powder has been completely dry, the G4 crucible containing the dry silver powder is weighed again using an analytical balance. The final mass is carefully recorded by subtracting the initial mass of the empty crucible from the final mass. We can determine the mass of recovered silver.
As for the result, we have mass of G4 crucible, mass of dried silver precipitate, and also mass of silver granules. For mass of empty G4 crucible, as you can see, it is 24.5632 gram, and mass of G4 crucible plus with the mass of dried silver precipitate is 25.0508 gram, and lastly, initial mass of silver granule is 5 gram. So we can conclude that mass of recovered silver precipitate is 0.4876 gram.
The last part of this video presentation is the conclusion. The experiment successfully achieved its objectives to understand the principles of precipitation gravimetry and to determine the mass of silver in the sample. Through this gravimetric method, the mass of pure silver precipitate recovered from a 5 gram initial sample was determined to be a 0.4876 gram, calculated from the mass of the G4 crucible with dried precipitate 25.0508 gram minus the mass of the empty G4 crucible 24.5632 gram. That's all.